and you can use your online book or your physical book. Okay, so here are some exercises what we will do. If you see page number 16. Okay, so but before this I want to tell you what is mBot robot. So as I told you before, the mBot robot is designed to teach robotics. Many new features are added to the mBot to make the design for artificial intelligence, yeah, AI and machine learning. I will show you in the class the physical mBot robot, and in this robot you will learn about the sensor, this yani the structure of the robot, or the motors, how we use the motors, how we make the coding, how we make the programming for to move this robots. Okay, if you go to page number 16, so you will find some exercises discovering the mBot hardware. I open from here. If you see page number 16, so it's better you use the online book, because you register already this book. So this is the exercises, and here you can see discovering the mBot hardware. Can it count of 5 elements? So now I will show you what is number one, what is number two. Okay, so again I come here, and number one you can see part. I make it zoom in, and this is we call CyberPi. Now what is CyberPi? CyberPi is basically is a programmable microcomputer that designed for teaching and learning. We can use Python for the programming in this. It's a small but features a full color display, multiple input device. Input device, you know what is the input devices? Like in computer, if I say input devices, so we have input devices, keyboard, mouse, the devices which we use to give the input. Okay, so they are saying the same thing, much larger storage and an assortment of modules and sensors. So when I will show you the physically in the class, so it will be more clear, but this is a very important part in the mBot. The motors. What are the motors? Now again we come here and we see motors are one of the primary mechanism by which robot moves. How we can move with the motors. Some motors can be attached to wheels that drive a robot around. Other motors might cause joint in a robot limb to move, yet other might move the control surface of a robotics airplane and submarine. If we talk about the motors in mBot, so mBot is equipped with two motors for the movement, an ultrasonic sensor for distance measurement and obstacle detection. So again, I will show you this in the class, and the physically when I will show you this mBot robot, so it will be more clear. Now we come on sensor. The sensor. What are the sensors? The sensors measure the time between sending the pulse and hearing the echo. Because the sensors knows the speed of sound in 340 meter, it can calculate the distance to the object that sound wave reflected. Basically sensors we use for different purpose, like if we want to move the robot, and in the programming we ask the robot to stop if it see the red light or red color. So the sensor is the one who will yani, um, as, realize, yes, this is the programming and I have to stop now. So we will see this sensor, how we will use it in mBot. Now we come the fourth part, this is its skeleton. Now you know the CyberPi, you know the motors, you know the sensors, and now the skeleton. So for the skeleton, you should know the main control board in the brain of mBot. The wheels and chassis are and the arms, leg and the body. Sensor in robot can often replicate of five senses. Yani like we have senses. Um, so this robot also there are five what we call the senses. And here if I come and I see this exercise, an LCD screen, a micro phone, and a speaker. The CyberPi, which is the brain of the mBot robot, is equipped with the following. Okay, so an LCD screen, a microphone, and a speaker. Okay, this is screen. You can see. You will find in the mBot when I will show you a joystick and two push button. This joystick is attached uh, with the mBot and you can use as a joystick. Five RGB lights. Okay, there are five RGB lights: red, green, blue. Then tilt, shake, motion, and rotation sensor. Again, they are talking about the sensor. Then the sound and the light sensor. Okay, this CyberPi contain these five equipped. Okay, now if we talk about more mBot parts, and if you see in your book, so they are talking about this. See, mBlock is the officially used to control the mBot robot. mBlock is the officially mBlock. This is the application what you can download in your mobile. It's a Scratch-based program. You know Scratch we used before, where we create the games or different types of program. The version of mBlock should be 5.4.0 or higher. Okay, so you can use more effectively. After that, you see here are some coding. They put it and they are giving the numbers. So examine the CyberPi, this joystick, what I told you before. The five categories of blocks are used to control the CyberPi. We discuss about it, the joystick and the sensor and these things. So again, they are telling you. Number three is extension. Extension means to be able to program the embedded robot. Click on extension. When we will do this programming, you will understand uh, better. Number four, they are talking about this RGB colors, what we call the red, green, blue colors. So examine the mBot shield and the two sensors, ultrasonic and RGB colors. Here, if you can see this, so this is RGB colors. Okay, click and on add to add the corresponding block. The mBot motors. Now, if you see the motors in mBot, so when you add the mBot shield extension, you notice that two new categories are added: the mBot chassis and the mBot extension. If I make it maximize this, so this and both extension. Okay, this one also when we mBot extension uh, chassis block. Now they are now you see category to the wheels. As I told you before, the motors uh, are the parts from where we can move the robot. Okay, so this examine the different blocks. If you see here, I make it zoom. So how we can move forward, how we can make it right, left, or up, down, how we can rotate this motors, these everything will perform motors. Yani motors are the main parts. Now, if you see controlling the wheel rotation automatically, so this is the coding. We will do this coding in mBlock application when we will install it. So you see you have the choice to control the rotation of the wheel either automatically or manually. So as I told you before, the motors are the one who give us the power to move left, right, up, down, and also to the rotate. By choosing one of the four block proposed, you can control the movement and rotation of the robot. So this is the coding, and this coding same like Scratch, what we did it when we were creating the games on Scratch. So we were doing the same thing, um, drag and drop the blocks, and after that what we want to do it like we want to go up, left, right, rotate. Both motors will have the same power, so you can steer to the left nor to the right. If we come on the next page, so the controlling the wheel rotation manually, you can do this automatically and the manually. So what you have to do for manually, to each wheel separately use the encoder blocks. This maybe you will be a little bit confused in this, but this is drag and drop. We will drag and drop, and manually we will give the speed, how much, yani in which angle we want to rotate, and we will take the encoder motors block, and then we will write we have to move left or right, or how what which degree we have to rotate, okay, and how much time it will take for rotation, any after 1 second or after 2 seconds it has to rotate or what. Okay, the encoder block is used to set the properties of each other. If you see this number one, this is block, or you see left wheel or right, or want to move it at one time, you want to move only one wheel or two wheels, so it's depend on you. The encoder motor block is used to set the properties of each motor. See this, left or right or all. So which wheel you want to move it, the left wheel or the right wheel or all four wheels. If you see number 3, the value of the rotation could be set positive or negative. Yani here you can write this um, what we called the value, yani rotate in which speed and which angle you want to rotate it. If the value of rotation is positive, yani left wheel rotates forward, right wheels rotate backward. If the value of the rotation is negative, left wheel rotate backward and right wheels rotate forward. So we will do this in practically when we will be in the class, and I will show you this robot. So we will work on it. Okay, moving in a maze. Build the mission, the make the robot moves in the maze using the joystick. The joystick is the same by CyberPy. If the joystick is pulled forward, the robot will move 40 centimeter forward. Yani, you use the joystick for FIFA or for the PlayStation. So the same thing we will do it here. Yani, we will use the joystick in the same way. If the joystick is pulled left, the robot will turn 90-degree left. If the joystick is pulled right, the robot will turn 90-degree right. And examine the block to control the joystick of the CyberPy. The same thing, CyberPy as a joystick, we can use it, and uh, again we will see this in the, they are talking about the sensor. You see this adding the ultrasound sensor. In the beginning, if you remember, I give you the example for yani if they we make the programming or the coding, and we ask the robot if it sees red light, it will stop. So this ultrasonic robot basically detect the object, or yani, if there is the object, it will stop. But you have to give the distance, how much distance it should take, yani before 1 meter. If it detect the any object, so it will stop or it will move it again. So like this, the ultrasonic sensor is used to avoid obstacle and to detect the object and distance. The same thing they are talking about, yani which distance we have the object, and the distance we have to mention how much distance we have to stop. To be able to use ultrasonic sensor, proceed as follows. You can see this is the ultrasonic sensor. Click on extension, select the ultrasonic and sensor to examine the ultrasonic. If I make it zoom now again, we can see the uh, brightness. We can write till the brightness. So this you will understand when you will see the physical part. Now measure, to measure a sensor, proceed the block. This ultrasonic allows you to measure a distance. Yani the same thing again, how much distance the robot should stop. To build a mission to make a robot stop at 10 centimeter from an obstacle, follow the steps below. This is the blocks. Yani when, see, when any of the program we will do, like if we were doing in the scratch. So first we will taking this when this green flag, okay, click. We will put this, and then the same thing what we were using in Scratch, we will drag and drop the blocks, repeat it until when this, okay, yani we are putting the condition or we are putting the loop, it will repeat until when this condition will be fulfilled, and then it will move forward, okay, otherwise it will stop. So the loop repeat until will be the repeating as long as the distance measured by the ultrasonic sensor is greater than 10 centimeter. This is the uh, greater than 10 centimeter. This loop will work. When the distance measure is less than, the robot will be stopped. Okay, there are some activities what we will do in the class, and here are some exercise. My robot avoid obstacle. Now it is to complete the previous mission in order to make the mBot robot move in the room without touching the walls. Yani we will create the program for the mBot robot. Yani we will move the robot, and if it see there is a wall, so it will move again, move left or right wherever we want. So we have to make the coding, and you will see uh, this coding in the class. We will do these exercises. So in the mission, I make it zoom. If ultrasonic sensor detect an object less than 10 centimeter, you see this is number one, and they are saying what will happen if we do this programming. You can see in your book, and you can do it. So if this number one, yani we will make the loop, so what will happen? So if ultrasonic sensor detect an object for less than 10 centimeter. Number two, when will the robot stop? When the robot, because when the loop will finish, when the ultrasonic sensor detect an object for less than 10 centimeter, and our loop is for 10 centimeter. Okay. Number three, they are saying once the robot detect an obstacle less than 10 centimeter, the robot will be stopped. Describe the scenario to be done by the robot in order to continue the mission after the first step. So what will happen after this coding? The robot must move backward for 10 centimeter, then turn 90-degree left or right. See, if it will detect the wall or any of yani, the object, it will move, it will turn 90-degree left or right. Okay, now The other exercise we see, this is the program, and repeat until, this is the loop. Okay, so what will happen if button A pressed? What will happen? Moves backward 10 centimeter until done. What will happen? Turn left 90 centimeter. So if you see his this, write a short oh, which one you were doing it? uh, okay, so examine the number 5. So what will happen after these thing? The block 2 will be placed in block 1. Okay, yani this block will be placed in block 1. Repeat until button A pressed. Then block 1 will include the above mission. Block 3 and block 4 will be placed under the block, yani this number 3 and number 4, it will come after this. Okay, for step to stop sensor motor, yani it will stop if the condition is not fulfilled. Okay, they are giving some more exercises. If you see, create the robotics mission to make the robot move once it detects an obstacle less than 10 centimeter. They did the same thing here. We have to do with our mBot. Okay, now if you come on page number 20, okay, this is page number 20, we have finished. 21, what will the 21, and now we come on page number 22. This is page number 22, yes. So you can see a gyroscope sensor to control tilt. Okay, what is gyroscope sensor? A gyroscope sensor is a small device found in many electronic devices like smartphone, drones, and game controller. When you move the device or change its orientation, the gyroscope can detect the movement and tell how the device is being moved or tilted. Okay, so this gyroscope device basically we used in different smartphones also. And why we use this, it can detect the movement and tell how the device is being moved or tilted. I make it zoom if you are not able to see scenario. The joystick with the scope sensor to different tilt position, left, backward, forward. Who will detect? Okay, examine the position. This is clock by screen, the tilt angle. If you see, uh, show you in the class how the gyroscope works, how you use. Okay, will show. Okay, this is the mBot robot is placed on the horizontal surface 0. Okay, guys, I want to tell you one thing. This one, it will be more clear when you will build the robot speed speed as follows. The robot speed 10 centimeter as long as the surface is horizontal. Detect the flow of the class. This is page number 23. So for page number 23, we come here and I show you, this is page number 21. So page number 23, this one, I make it zoom. So what they are saying, my robot climbing a slope. You see, this is there is the coding, okay, and this coding, they are saying what the robot will do. When does the mission start? I told you every time when the green flag is clicked. You have to put this because once we put the green flag, then uh, the mission or the program will restart. At what speed will the robot move forward? You have to see at 7 round per minute. When will the robot stop? -5. They are putting the condition here. This if this will be -5 or less than -5, then the robot will stop. Okay, explore more. So since the tilt angle of constant, and this also they are giving one quote, and they are saying measure the length of the slope, complete the mission above in order to make the mBot robot move across. Okay, again they are giving the challenge and add the track another horizontal path that ends to the obstacle and let the mBot robot accelerate the speed. Okay, this is the challenge. What we cannot do here, we will do in the class. If we come on page number 24, so here they are saying about the distance, calculating the distance travel. Yani there is a wall, and as I told you before, this one the we will make the programming and we will give the distance, or we will make the loop, or we will make the condition. How much distance if the robot sensor will detect, so it will stop when it will the sensor will tell the robot, yes, in 10 centimeter there is the wall or there is any object, so it should stop. Okay, examine the robot in the room. It could be placed at the variable distance from the wall. See, there is the distance between the wall and the motor. The main issue is how to make the robot move on the wall and get back to its initial position. This we will mention in the blocks how much distance should be, and we'll make the loop. Yani if distance is greater than or less than 10 centimeter, it will move forward or backward. The only accurate technique to do this, the mission to calculate the number of degree the wheels have performed. The same thing, and if this is the distance, the robot will not go straight. The robots will take left or backward or right. Okay, and after this the robot will go on the other position, and again if we see the ball, it will stop. Write down the formula to calculate the perimeter of a circle. So the formula is 2 pi r. We call this sign we call pi. You see, this one we call pi, so 2 pi r. Okay, calculate the perimeter of the different wheels down on the left. This one we are going to do in the class. This one page number 24, and now we are on page number 25. I make it zoom. See, they are talking about building the script. Now they are talking about how we will build the script. Yani as I told you before, this is like the scratch, drag and drops the block, and we have to give the values, which value for the distance, the loop until the motor will not stop until the loop is going on or there is a condition. So as long as the robot is turned on, all the rotation of the wheels are stored in the encoder motors, resetting the encoder motor. The block, so the first thing they are saying, the block encoder motor all means the wheels, all wheels, not only one, all the wheels. Okay, rotated angle will reset the value of 0 the encoder motors. Yani if they are writing left or writing right, that's mean only right or left wheels will move. But if they are saying all, that's mean all the wheels. The script 2 allows you to this one. If we write this code, you can see in your book, this is the loop again, repeat until ultrasonic to one distance, any 1 centimeter distance of an object this less than 5 to make the robot move at speed 50 and stop once the optical is detected for less than 5 centimeter. less than 5 centimeter. This is the condition. We can change the value. So this value robot will take and through the sensor. Okay, ultrasonic sensor. What happened when the robot detect an obstacle for less than 5 centimeter? We are putting the loop and we are saying if less than 5, so the motor will be stop. This stop motors all, any all wheels. Okay, so the answer it will stop. Examine the block to calculate the distance traveled by the robot. Number 4, they are saying this. We have to do this coding, and this coding we will do in the application. So you should have the mBlock application. You can do easily on the mobile or on the computer. List the variable used to calculate the distance traveled by the robot. Okay, so they are asking about the list. So degrees, rotated, circumference, distance travel. This one, these are the variables. Variables are the basically the storage, the place where we store the value. Okay, so these are the variables. So these variables we use in the mBot. The variable degree rotated is used to, why we will use this degree rotated. Okay, so it will save the value of rotation in degrees, yani which degree it should move. Yani if there is a wall on the front and the ultrasonic, the sensor detect less than 5 centimeter, so it will rotate. Okay, the value of rotation made by the encoder motor 1. Number 7, the variable circumference is used to. Circumference variable, why we use, I told you variables are the place where we store the value. The variable circumference is used to will calculate the perimeter of the wheel. Okay, number 7, if you can see the circumference, this one variable was degree rotation. Now the third variable distance travel is used to, this one. Why we use the distance travel is used to store the value. As I told you, it's the variables we use to store the value. The store the value in centimeter in the distance traveled by the robot. Okay, here again they are giving the challenge. This challenge we will do in the class also. Complete the mission above to make the robot go back its initial position. Okay guys, for now I stop this video here.